Now to continue to the Riemann hypothesis, how you figure it. Now the problem with this, when constructing this with a compass and straight edge, even there you can see I can do a 36, and technically this is a 72. You get the division there, as well as you have a 60 inside the ones when you draw the line, all the points. If I expand it out with my compass, 60. If I want to trisect that, then I can now get 120, or excuse me, 180. Bisect that into 360. Same with this, 72, 144, or trisect it out. Now even with this, once you get a point in here, and you could take that, you have two right angle triangles, and you're constantly dividing that out as well as I'm trying to figure out the area on there using the Pythagorean theorem to go with the 1.2. But to put it simply, now the problem is to get the to be able to get like every prime number, for instance, would be a completely different on this. I could do 5, 6, 7, 8, 9, 10 on there, but still 11, 13 is an instance has to be redone. So the problem is figuring out a method that would work on all things. There. Now if you take the flower of life or the fruit of life, you can span it out. Now here, so my son, when I showed him tried to set the angle before he took it, he was like, oh, I could do it, and he tried to send it back to me, and I said, oh wait, but that's just doing the angles. But then I realized that this gives the sections of it, and if you could keep drawing it out, you could do the segments, simply calling these vesica Pisces as 1, 2, 3. Now you can't start the 0 point because it has to be defined within 2, and you'll see. So to going, or I'll expound that later, but the problem is here you can see the angles are split by the one line when you come up. Now to do the arc, if you come up and with your compass and put an arc on each one, you'll see that now the problem is to get the degrees, you have to transduce that line to this. And this at the bisecting it is dead on, as you could always bisect an angle before easily. Method going between is just explained right there. But now to trisect it, the fine thing is after figuring it, I realized suddenly that the next one is just straight on the perpendicular of the line below. Just take the perpendicular and do that to the arc, and now you've got the degrees of 20 degrees in there. If you take it out, and there you can see the two were off, but but now the new line in there is right on the 80 and the 100. You see, and you can take that, draw that out to there. But now you take that on, run it out here, and you can see on the circles in each one, you can count the vesica Pisces, 1, 1, 2, 3, before, and each one that's on the green line is straight out on the perpendicular, and you can draw it and you get the exact degrees breaking it out. And you notice that the arc of the 6th line hits on the 7th, and the 2s are always on the points, and 3s bisecting are always at the points of the 6 and the 9. But then you also, I realize that if you take this and measure straight down to transduce this line, measure 20 millimeters to 24 millimeters, you get the 1.2 difference in essence. Now to make that, but now that you have this, you simply move it down by half, because you can just fractal it down. The same principle as the golden ratio. And now to pull that out, now this shows the Riemann hypothesis, how z times 1 plus 1/2 s plus 1/3 plus 1/4 repeating give you the prime numbers Here's the graph of the zeta function showing you the Riemann hypothesis, or proving it. In essence, you can see all the lines coming down are all, well, this one case was 25 millimeters to 30, giving you the 1.2 to the curve, to the arc, and the 1/2, 1/3. Well, originally I started, this was only, on this one I start with 4 circles on this side, 5 up here to get 5, and then just fractal it down. 0.1/2 fractal to get the 1, 2, 3, 4, 5. I could done it, get the half there is actually demonstrating the 1, 2, 3, 9, 8. But you can see the circles are the prime numbers. You can see where they verge always on the 0.5 line, coming based off the perpendicular to the axis of the 0 line. But this also explains the square root of 1, Ramanujan's numbers, as well as the Birch-Swainson hypothesis, and oh, that's the other one. It gets, it's 3 of the Millennium Prizes are gone there, and technically you get MP equals P as well, because now you can turn any polynomial curve or non-polynomial problem into a polynomial math problem based on this. I can basically get the arc in any division, the 7s, the 8s, divide it down, I get my prime numbers, fractal it down to the point that I want. In essence, even there, so the theory is that always that merges there, you cannot put it on the 1 or the 0 point, or it won't be defined, in essence.